problems have a force problem and a trajectory problem linked together, there's one key element in solving the problem correctly, and that is finding the velocity at the moment where the force problem ends and the trajectory problem begins. Let me give you a couple of conceptual examples of what I mean. We did a problem in trajectories 2 with a ball that was pushed off of a table. And as that ball was pushed, the table supported its weight, so only the sideways force that gave it a speed mattered when we did the dynamics problem to find the acceleration of the ball with force over mass, and then the final speed of the ball with a times t. In that problem, the time that the ball was pushed was given. But the key to the problem was right here. When the push ended, the ball was moving sideways. So the VF of the interval while it was being pushed became the Vx for the trajectory. Now from that point on, the trajectory of the ball could be found using that Vx and other information that was given in the part of the problem out here in the trajectory. And all the information that was given here about the dynamics of the push on the table stopped mattering. So the key to solving any kind of force problem linked to a trajectory problem is right here. Finding the speed at the moment the force problem ends and the trajectory problem begins, assuming of course that that force problem starts the trajectory. Well, I also mentioned that direction is important. Let me give you another example to highlight why direction is important. Let's say that an object is thrown like a football or a tennis ball. If an object is thrown like that, typically in order to make sure it goes a long way, the trajectory will start with an arch. Now since that velocity is neither just straight sideways or straight up and down, it's a combination of some Vx and some Viy. If there's a force problem that precedes the trajectory problem here, where you know some dynamics like force and mass, which could lead you to acceleration, assuming that the force is the net force, or if you knew some kinematics, if you knew about the distance over which it was accelerated or the time over which it was accelerated, then you could calculate the final speed of the ball in this interval while it was being thrown. Now that interval ends, of course, right here when the ball is released and it goes into the trajectory. Now this same sort of logic could be used for a bullet that leaves a gun or an arrow that leaves a bow. But in any of those cases, the most important thing to find would be right here the final speed from whatever got the object moving. But instead of being Vx as it was in that previous problem, because it's launched at an angle, it would be the Vi in the xy direction. And once you had that value, and hopefully this launch angle, then you could break it up into Vx and Viy and solve the problem as if that had been given originally. Now, one more situation that it's good to think about, and that is, what if the trajectory ends with a force problem? So let's take a trajectory that starts horizontally and then comes down and hits something. Maybe this is someone running off of a diving board and landing in the water. And when they stop, they come to rest over some sort of distance. Obviously, when you hit the water, eventually you'd come to a stop down here. Vf would be 0. Well, in order to solve for whatever forces are going on in the water, you'd first have to do some kinematics and find the acceleration that went on from the moment the person hit the water till the moment that she came to a stop. Well, if VF is 0, then VI would be nice to know. And of course, in this kind of trajectory, at the end of the trajectory, right here, the person would be moving both sideways and down. We'd call that a VF in the XY direction. That velocity is the VI, which is clearly not 0, of the next interval that starts right there. So the direction of the velocity at the moment that the trajectory either starts here or here, or the moment that that trajectory ends here, is very important, because that direction tells you whether the velocity in the trajectory should be a VFXY, a VIXY, a VX, and so on. You can imagine, of course, that if you threw a ball straight up, the final speed as it left your hand would become VIY, because of the direction you threw it. So, as a general rule, when you are solving trajectory problems that are linked to force problems, you're going to have kinematics and dynamics while the object is being accelerated to start its trajectory. And the goal of that is to find the final speed it has as that dynamics and kinematics problem ends. That becomes the starting speed of the trajectory. Simply be careful whether that starting speed is a VX, a VIXY, or a VIY. Depends on the direction it was moving at the moment the trajectory began. Thanks for listening.